Oh, hello. Didn't see you there. Just kidding. I did. Welcome to our next unit. All right, we're going to start with um, lesson 6.1a. What is a system of linear equations? This entire chapter will be about systems of linear equations and then inequalities. We're going to start out today with just learning what is a system of linear equations. All right. Goal today, we want to identify a solution. What is a solution? What does it look like? And what does that mean? And then we're going to start classifying some of these systems of linear equations. So here it is. This is what a system is. All a system of linear equations is when there's two or more linear equations together. Right? That's it. We're going to be dealing mainly with two. All right. We're not going to do more than two or three. We're going to be just dealing with two linear equations. And now, what a solution to a system of linear equations. That is the longest vocabulary word I think of the year. Not kidding. So a solution is going to be an ordered pair. That is huge to recognize, okay? The solution, meaning the answer to a system of linear equations, will be an ordered pair, parenthesis, x, comma, y, parenthesis, okay? It makes all the equations true, okay? Being both of them, because like I said, it'll be two equations. So now, let's get into some nitty-gritty of what it actually will look like. Here's an example. There it goes. Here's an example of a system of linear equations. It's just two equations. Y equals x plus 2, y equals 3x minus 2. Okay, that's what a system is. So now, is this a solution? All right. What do you think we should do to figure out if 2 comma 4 is a solution? What do you think? All right, I hope you came up with one of the choices that would be right. We would pretty much plug in the 2, which is our x, into the x values of the equation, replace them, substitute them in. Then I'm going to take this 4, which is a y, and I'm going to plug it into that top y, and I'm going to plug it into that bottom y. All right, so I'm now going to substitute the x and the y value into the equation, replacing x and y with numbers. And I'm going to now get down here. Instead of y, I replace it with 4. So I now have 4 equals 2 plus 2. Wait, does 4 equal 2 plus 2? It does, which means this ordered pair satisfies the top equation. It works here. Now I have to go and check the second equation, which is down here, the second one below. Does 4 equal 3 times 2 minus 2? Well, does 4 equal, that's 6 minus 2? It does. It satisfies both equations. That's what it means. So that ordered pair, 2, 4, is a solution to this system. All right, now we're going to get into some classifications. I'll move myself when I need to. A system, there's a couple different options of how many solutions it could have. If a system has at least one solution, it is called consistent. If it has at least one solution, it is consistent, okay? You may need to pause this along the way just to kind of catch up with the notes. A consistent system, meaning if it has at least one solution, can either be dependent or it can be independent. All right, so if it's consistent, meaning it has at least one solution, it can branch out and have two different parts. An independent system has exactly one solution. So it has one ordered pair that will make it true. Okay, so it's consistent, independent, that means it has one solution. If it's consistent, dependent, it has infinite solutions, which means there are infinite ordered pairs that we could plug in and make it true, and make it true, and make it true. All right. And now there's the third type, a system that has no solutions. No solutions is inconsistent. All right, so it's consistent, which can be broken into dependent or independent, or it's going to be inconsistent. And now I'm going to go over what these look like. A system with one solution, will have different slopes for each equation. All right, they have different slopes. So in order to tell how many solutions a system has, we pretty much need just to find the slopes first. Okay, so if we identify their slopes, and they are different slopes, different numbers, all they have to be is different, then there's one solution. One. What about infinite solutions? Well, what classification would that be? All right, hopefully you got that. What does that look like? Well, infinite solutions, these have the same slope and same y-intercept. So it's the exact same equation. So if you have two of the exact same equation, there's going to be infinite solutions because anything you plug into one will also work on the other. It seems pretty simple, but of course, here I have a system, y equals negative 3x plus 9 and 6x plus 2y equals 18. They're different forms. In order to tell how many solutions they have, we want to find the slope and the y-intercept. The first one is done for us. We already see the slope is negative 3 and the y-intercept is 9. The second equation, I need to transform that into slope-intercept form. So what's my first step going to be to do that? I hope you came up with, we want to take away 6x. We want to isolate the y. So we want to subtract 6x, okay? Isolating the y by subtracting 6x first. That leaves us with 2y equals negative 6x plus 18. I want to isolate that y, so I'm going to divide both sides by 2. And now I'm simply left with y equals negative 3x plus 9. Oh my goodness. That's what I started with in my first equation, and the second equation turned into it. Therefore, there are infinite solutions to this. This is consistent, and this is dependent, okay? A consistent, dependent system. Lastly, what about no solutions? That means there's no ordered pair that you can plug into both of them to make it true. You can't do it. So what does that look like? Well, this one's a little bit similar to the previous one. They have the same exact slope, but they have different y-intercepts. Little tiny details. You might need to pause again to catch up with some of these notes because I'm going kind of fast. And what does that look like? Well, an inconsistent system looks something just like this. Same slope, different y-intercepts. Okay? That's it. Here's your work. All right, good.